Okay, so in this case, what we're trying to do is work out the formula of this hydrated compound from its mass, right? And so here what we've got is sodium thiosulfate, and we've been told that its mass has been determined as 10.15 grams, and when the water's all removed, the mass is 6.55 grams. And so we need to effectively use this information to calculate the value of x, right, the coefficient for the H2O. And okay, so how am I going to approach resolving this? Well, if I take a look at the molar ratio, right? So the thing with this is that we've got this component. So if I just we've got this component and we've got this, right? If we compare the molar ratio between the Na₂S₂O₃ and the H2O, so we can see that the coefficient for this is 1, right? So if we can work out for every 1 mole of this, how many moles of H2O do we have, we can then work out the coefficient. So we're going to go through that process. So we're going to need to work out the molar mass of both of these. So I'm going to do the sodium disulfate first. So that's Na₂S₂O₃, right? And I've got some parts of the periodic table here, right? So relevant would be the sodium, sulfur, and the oxygen, though, you know, I can get rid of this since I do have oxygen in 2 places on the hill. Okay, so Na₂, so that would be 23 times 2, and then S2, so that would be plus, so 32.1 times 2, and O3, so that would be 16 times 3, right, plus 16 times 3, okay? And so if you work that out, what you should find is that you get 158.2, right? And that's going to be in units of grams per mole, right? Now, the other thing here is we also need to work out the number of moles of the H2O, right? So for H2O, it's actually going to be well, it's going to be 1 times 2, right, for the H2. So let me just 1 times 2 plus 16, which is going to be, I mean, it's going to be times 1, right? But so I just leave it like that. 1 times 2 plus 16. So that's going to be equal to 18, right? And again, that's going to be in units of grams per mole, right? Okay, so we've got these 2 values, but what we actually also need to do is work out the mass of the mass of the H2O, right? So how can we work that out? Because we do have the mass of the non-hydrated sample, which is this, but we don't have the mass of the H2O. But that's just simple arithmetic. So if you want to work out the mass of the H2O, that's simply going to be the original mass. So that's going to be 10.15. And we subtract from that the mass of the unhydrated sodium thiosulfate, so that's going to be minus 6.55, right? And that's going to give us what our H2O mass is. So that's going to be 3.6, okay? And that's going to be in grams, okay? Now, what does that help us do? What that helps us do is we can now use this to work out the number of moles of H2O. We already have the mass of the sodium, the molar mass of the sodium sulfate and its mass, so we already got the building blocks for that as well. And if we remember, the formula relevant here would be that the number of moles N is equal to the mass M divided by the molar mass, okay? So in the case of the sodium sulfate, the number of moles of Na₂S₂O₃ is going to be equal to the mass M, so 6.55, divided by the molar mass, which, as you know, is 158.2, right? Alright, so if you have a go and working that out, you should find what the number of moles is for this. And if you do that calculation, you should find, I'm going to give my answer to 5 significant figures, but this is going to be 0.041403, right? And that's going to be in moles, okay? And we can now do the same for the water using the same formula. So the number of moles for the H2O is going to be equal to, well, we worked out the mass to be 3.6, so it's going to be 3.6 divided by the molar mass, which is 18, okay? And if we do work that out, we find is that this gives us 0.2, right? And that's going to be in moles, okay? So we now have two values, and what we're going to do is we're actually going to set up a ratio to compare the two. So we're going to say the number of moles of the Na₂S₂O₃ compared to the number of moles of H2O, right? And we know that on one side we've got 0.041403, and we know that on the other side we've got 0.2, okay? And what we effectively need to do is we need to get, as I said, we need to get this side to be 1, okay? Because we know that the coefficient in the original formula here is 1. So for every 1 of the Na₂S₂O₃, how many moles of H2O, right? So really trying to figure out the ratio. How can we get this side to be 1? Well, we can do that by dividing it by itself, and then, you know, you do one thing to the other side, you need to do it to the other side as well. So effectively you then divide this by 0.041403, and you'd also divide the other side by the same 0.041403, okay? And so that's going to then give you a new ratio, and it's going to effectively be 1 on one side, and then the other side is going to be so I'm gonna round this. So it's going to be 4.8306, okay? And at this point, we have 1 on the we have a 1 on the left hand side. So what we can actually do is say that, well, because of that, we're going to assume that this is actually it gives our approximate answer, but we can round it up effectively. So if we're rounding in this case, we're going to be rounding up, and so this is going to give us effectively a ratio of 1 to 5 effectively. And what does that tell us? Well, it tells us that what our formula is. Therefore, the formula, well, before we get to the formula, let's focus on the value of x, right? So therefore the value of x, well, therefore x is equal to 5, right? And therefore the formula is equal to Na₂S₂O₃ dot 5H2O, right? So this is what our formula is going to be, and that is our answer, right? So what we can do at this stage is to just go back to the top and say, well, this is going to be, let me use a different color. We can say that this is going to be a 5 in here, right? Okay.